Have you ever thought about why floor diaphragm is required on each floor of a building when analyzing it? Do you know what will happen if we don't provide it? Then you are welcome to my channel. In this video, I am going to discuss about all of this. If you are new in my channel, don't forget to hit subscribe button to get this type of video in future. Before dive into the floor diaphragm topic, I want to tell you what is in plane and out of plane deformation. To understand this, look at this cantilever slab. These two ends of the slab are fixed and these two ends are free. Now we are applying two types of loads on it. First one is the sail point of the slab and the second one is joint load at free end and the load direction parallel to the length of the slab. Due to this sail point of the slab will deform like this. This type of deformation is called out of plane deformation. Due to the joint loading, the slab will deform like this. This deformation is called in plane deformation. Now coming to the floor diaphragm topic. In a residential or commercial building, generally we provide 100 to 200 mm thick RCC slab. So these slabs almost have infinite in-plane stiffness, while it will have a finite out-of-plane stiffness depending upon the slab thickness. Since it has a infinite in-plane stiffness, we can assume it will act as a rigid floor in terms of in-plane effects. So if we apply a floor diaphragm in a floor, it means all the node will act as a rigid floor and we are adding extra constant equation to these all floor nodes. This floor diaphragm will evenly distribute the lateral load in the lateral load resisting element. So it is essential to apply floor diaphragm in each floor to accurately analyze the structure against lateral load. When we are analyzing it in software, it will create a mustard joint at the center of mass of that floor. Using this lateral load, it will calculate the rotation of the mustard joint about vertical axis and rotation will distribute to the other nodes depending upon the floor flexibility. So that's why we can apply two types of floor diaphragm. One is called rigid floor diaphragm and second one is called semi-rigid floor diaphragm. So if we provide rigid diaphragm, it's mean all the floor node will have the same rotation about vertical axis. But if we provide semi-rigid diaphragm, it's mean all the floor node will not have the same rotation about vertical axis. So the rotation will depend upon the floor flexibility. Now I am coming to the next topic. What will happen if we don't provide any floor diaphragm in a building when we are analyzing it in software? To understand this effect, we are considering three cases. Case 1, building without diaphragm. Case 2, building with rigid diaphragm. Case 3, building with semi-rigid diaphragm. In these three cases, the building have same material properties, section properties, loading and geometry, but only they are different in terms of floor diaphragm. I have used ETAP software to analyze these three buildings. This is the building without any floor diaphragm. In this building, I have applied these lateral loads. After analyzing these three buildings, I have exported joint reaction in Excel file to compare the result in three different cases. And here you can see this is the Excel file. I have exported all the result here. So this is the result for without floor diaphragm. It's mean case 1. So in this case, we can see that the rotation about vertical axis, it means Z axis, is different for all the nodes. Here you can see the different value for each nodes. But in case of case 3, the rotation about vertical axis is remains same for all nodes for a particular floor. So here you can see for story 4, the rotation about particle axis is same for all nodes, and also for story 3 this rotation value is also same for all nodes. In case of semi-rigid diaphragm, it's in case 2 the rotation is not same for a particular floor. So if we apply floor diaphragm in a building, it will add a rigid floor effect in the building, and also it will help to evenly distribute the lateral load in the lateral load resisting element. So that's why floor diaphragm is very important when we are analyzing a building using software. And if you don't know how to add floor diaphragm in StatPro software, then you can click on this video. Here I have clearly described how you can apply floor diaphragm in a building. So if you find this video is helpful, please like and share this video to your friends.